Hi, everyone. I just want to share my thoughts on Module 6 with you, problem-based learning and contextual learning. So first, I want to talk about question 2, that concept where we gave you 2 problems, and we wanted to see some discussion about whether the problems were contextual or procedural. And most people started off by answering that both were very procedural. And then later on, some people started talking about that the first one might be more contextual. So Devin's comment about the fact that procedural and conceptual understanding are not mutually exclusive, but I do think that procedural understanding is within conceptual understanding. So if you're building conceptual understanding, it means you're getting procedural understanding as well. But if you're only building procedural, you might not be getting contextual, or conceptual understanding. So what my opinion is about those two questions is that, and they weren't created by me, but the second one is extremely procedural. It just says to solve the equation. The first one, I think that that's a more conceptual problem than the second one. That's all. I'm not saying that it's the be all and end all of conceptual understanding, but it asks students to explain what the math in each step is. So I'll give you an example. Somebody, I'm not sure who, but in their post explained that one of the steps is to cross multiply. So in my classroom, to show conceptual understanding, we can't use the term cross multiply. The reason is because cross multiply isn't a mathematical thing. If I have a denominator of 4 and a denominator of 7 on the two different sides, cross multiply means multiply one side by 4 and the other side by 7. That's not actually what's happening. What's happening is that we multiply both sides by 4, and so that makes the fractions cancel, and we multiply both sides by 7, and that makes the other fractions cancel. So that idea of keeping a balanced equation, that's a mathematical concept, because we have an equal sign, and that equal sign says that whatever we do to one side, we have to do the other side to maintain equality. And so multiplying both sides by 4 and both sides by 7, that's a mathematical thing. But cross multiplying is a shortcut that we've created, and that confuses students because, what's to stop students from cross multiplying when they have 3 over 7 plus 4 over 6? A lot of students then go to cross multiplying 7 and 6, right? Or when you're multiplying 3 over 2 times 2 over 6. A lot of people cross multiply, right? Because it's just a trigger in their head that when you have fractions, you have cross multiply, and students don't understand why. Another thing is to always try to keep that balancing equations in mind, because, for example, and the fact of opposite operations. So if we have 3 divided by 2 or x divided by 2, to undo that divided by 2, we have to multiply by 2 because that's an opposite operation. It's the inverse, which then gets developed through the years. The really telling point of whether students understand this or not is in grade 10 when we ask them to do sine and sine inverse, right? So students will have, for example, sine x is equal to 1/2, and the answer that you'll often get on your test paper is that x is equal to 1/2 over sine, because we're dividing by sine. And students aren't understanding the fact that it's actually sine inverse because you're undoing the operation of sine, right? So that's why I really like the idea of opposite operations and always sticking to math terminology to develop conceptual understanding. Okay, now on to PBL. And there was a few people. One, Amanda, brought up the idea that parents always bring in their school experience as a bias. And it's a huge challenge, and we do have to re-educate parents on this. The other thing is that not all students will buy into PBL. We definitely know, research says that PBL is a stronger way of teaching and a stronger way of learning. But students need to buy into this. And the best way that I've seen students buy into this is if we put the rubrics and the learning in students' hands. So what I mean by that is there's something called a learning map, which is basically curriculum created in student-friendly language, which I do over the course of a semester with my students. A really good example is from a book, Rethinking Letter Grades, which I'll put in the links after this video. But when you give that to students, when you give a learning map to students and you have them track their own learning, that's when they buy into PBL, because they see that they're making progress. They really just want to sit there and have you tell them things, but that's only because they think that that's easier. It's not necessarily because they think that it's better learning. So we do have to unlearn some things from students as well. Other people also talked about 21st century learning, which is a huge in this module, because PBL does support 21st century learning and modern learning, whereas traditional math class, there isn't a lot of space for modern learning. We really have to be careful about how we ask the questions. I just want to also bring up Jesse's point along with many others, and it's that PBL doesn't replace traditional learning. And PBL doesn't mean that there is no procedure and basic skills. It's just that the basic skills are embedded in a bigger context. Okay. Now, I just want to share a couple of resources with you, which will help you with your PBL journey, because some of the feedback that I did get on that feedback survey was that people wanted to see more math resources. So bear with me for a second. This is the book, Rethinking Letter Grades. It's an extremely quick read, and it doesn't mean that you're getting away from letter grades, but what it does do is it gives you some alternatives as to how to have students self-assess and how you can give better feedback to students. So the first one that I want to show you is Dan Mayer's 3-act tasks. This was, like it says here in the description, it was my Bible when I started rethinking how I teach math. And it's literally all of the things that he's done, created, and free for sharing. And you can see that up here it goes all the way to 2017. So he is still creating lessons and helping teachers that way. Okay, and the other one is Robert Kaplinsky's lessons. Kaplinsky is another math guru out of the US, and he's got really engaging lessons for students that are problem-based. This is one of my favorites, How Can We Save Nelly? It talks about his financial troubles and how many songs people have to listen to on Spotify in order to get him out of the financial troubles. I do hope that will help you with your lesson planning and all that when you do get going. And we'll talk again in the next module.